Question number 14. A mass connected to one end of a rigid rod. This is your rigid rod, not a string. At constant speed in a vertical plane. That means what? It is under gravity also. About the other end of the rod. It's connected here. The force exerted by the rod on the mass. By the rod on the mass. What does it mean? That means it is pulling. Right? The rod is pulling the mass. So he is asking you this force. Is zero everywhere? Is it so? Definitely not zero. Okay. So therefore, because when if this is the case, then definitely, so if the object is here, it has to pull it like this. So therefore, it is not zero everywhere. Constant in magnitude, definitely it is not constant. Why it is not constant? Because you see, when it is going upwards, at this position, see it says constant in magnitude. So at this position, this is your mg. If I write the free body diagram, here it will be T minus mg is equal to mv square by r, right? Let me say this is TA. TA here should be equal to mg plus mv square by r, right? If I take this point, then what will happen? This will be TB. If I take this point as B here, TB is acting here like this. Mg is also acting like this, right? So TB plus mg is equal to mv square by r. I did not change the v because it says constant speed, right? So TB should be equal to mv square by r minus mg. See, here the tension is very, very low, and here the tension is maximum over here. Minimum, maximum over here. So constant in magnitude, no, it's not constant in magnitude. This is also incorrect. Always directed towards the center. Okay, now you have to look at this. Say for example, now if you look at the force here, it is directed towards the center. Let me take up one more point. See here. Now you see, there is a tension acting here. There is an mg acting here. Now, what is the resultant force? The resultant force will act like this. So therefore, it is not always directed towards the center. It may be somewhere at some other point also. Except for this position and this position, it will be acting at the center. If I take any other arbitrary point, if I take this point, md is acting like this, t is acting like this, resultant will be like this over here. Okay. So therefore, it is not always directed towards the center. Many times we think this is right, this is incorrect. A minimum at the top of the circular path. We already achieved this, so therefore this is the right answer. Okay.